Computer technology is constantly evolving, and has come a long way since the Commodore. But compared to where it could possibly go, we have barely scratched the surface. Quantum computers are the industry's next obstacle, but boy, will it be worth it. Imagine you just went out and bought the fastest computer available. The ads promised lightning speed and major capability, and it all turns out to be true. You're thrilled with your new purchase. But wait, how impressive is it really? Computer technology is still relatively new, and our hardware and software is still pretty primitive. Think Model T versus Bugatti Veyron. In fact, there's an infinitely more powerful machine that you carry around with you every day, your brain. Now imagine if your computer could work just like your brain. Quantum computers are computers that operate like brains, using atoms and subatomic particles to process information. Instead of running in a linear fashion like the computers we know today, quantum computers will operate in more of a branching fashion, making connections and seeing patterns instead of simply processing data. Your computer processes information in bits. Bits are the most basic building block of the data world, and can either be a 0 or a 1. The particular combination of 0 seconds and 1 second is what tells the computer what to do, representing data. Yes, they get recognized and processed incredibly fast, but they still get processed one at a time. The data in a quantum computer is processed in qubits, basically quantum bits. Like bits, qubits can also be a 0 or a 1 but they can also be both at the same time. This expands the processing capabilities infinitely, and means that the quantum computer could process information with all possible values of the input parameters. The advent of a practical quantum computer opens up a huge array of possibilities in just about every field. Information is processed so much faster, incredibly complex calculations can be run easily, enormous databases can be searched as easily as a book index. Mathematics, science, engineering, medicine and even the arts would take giant leaps forward. Our potential is only limited by our technology, and taking away that limitation could launch the human race into Star Trek capability. For instance, creating a computer that functions like a human brain is the first step in creating true artificial intelligence. Think about it, as advanced as modern robots are, they are still just responding to a set of commands programmed by the maker. The longer and more complete the list of commands, the more realistic the robot, but it's still basically reading from a script. A quantum computer would give that robot a real, actual brain. Left unfettered, the robot would respond and act according to those millions of instantaneous connections the same way you do. It would reason, react and predict just like a human being. The all will not be roses when quantum computers finally hit the scene. First of all, they require a whole new type of programming. If you were to program a quantum computer using the algorithms your current computer uses, it would act just like your current computer and process information the same way. But if you use algorithms designed to take advantage of the quantum computer's full capabilities, amazing things start happening. One of those amazing things is pattern recognition and lightning-fast calculation and processing. Scientists at AT&T Bell Labs devised an algorithm for factoring very large numbers. This problem is so difficult that it's the math upon which modern encryption technology is based. Loaded on a computer like the one you're on now, it would take about as long as the universe has existed to break a typical encryption. But loaded onto a quantum computer, taking advantage of the both nature of qubits, the encryption would be broken in seconds. This means that no digital data would ever be safe, because the infinite computing power to break any type of encryption code would exist. Don't hold your breath, don't start worrying about your credit card numbers and your internet history yet. We're still a long way away from practical quantum computers. In 2000, Los Alamos researchers were able to use magnetic resonance to line up a few atomic particles to mimic information coding equal to about 7 qubits. It was in a drop of fluid. The next year, Scientists from Stanford and IBM managed to find the prime factors of 15 using another 7-qubit quantum computer, but it wasn't until 2005 that anyone managed an 8-qubit computer. By 2007, researchers at a private company claimed to have achieved a 16-qubit computer that actually solved a Sudoku puzzle, but their methods were questioned for practicality and scalability, and apparently assumptions were made that could not be verified. But think about this. Your current computer processes billions of floating-point operations per second, gigaflops. A 30-qubit quantum computer would process 10 trillion floating-point operations per second, teraflops. Sure, we'll have to completely rethink data security and AI ethics, but still, how cool will that be?